Today we will be discussing solving rational equation. Now let us try number 1. Our direction is find the solution to the following rational equations. Number 1, 1 over x is equal to 2 over 3x minus 1. So we're going to find the value or values for x. So there are two possible ways to solve this equation. The easiest one is using the cross multiplication. So to cross multiply, 3x minus 1 times 1. So that is 3x minus 1. Copy the equal sign. Then x times 2. That is 2x. Now combine like terms. So 3x minus 2x is equal to positive 1. Next, 3x minus 2x, that is x is equal to 1. Okay. The other way is using getting the LCD. Let's say, the other way is, I will write my solution here. So I'm going to transpose 2 over 3x minus 1. So that will become 1 over x minus 2 over 3x minus 1 is equal to 0. We transpose 2 over 3x minus 1. Now find the LCD. So our LCD is x times 3x minus 1, our denominator. So x times 3x minus 1 divided by x, that is 3x minus 1 times 1, 3x minus 1. Next, x times 3x minus 1 divided by 3x minus 1, that is x, multiplied by 2, negative 2x is equal to 0. And next, combine like terms in our numerator, 3x minus 2x, that is x, then copy minus 1 over x times 3x minus 1 is equal to 0. Now, our denominator multiplied to 0, that is will become 0. So next will be x minus 1 is equal to 0. And now, x is equal to positive 1, which is the same. So, you will choose which method you're going to use. You can use the easier one or the moderate one. Now, I want you to try number 2. X minus 2 all over 2x plus 4 is equal to 1 over 5. If you want to try, you can pause the video. Then after answering, resume watching. Okay, let's try. Let's use the easiest way. Cross multiply, that will become 5 times x minus 2. Next, 2x plus 4 times 1, that will become 2x plus 4. Distribute 5x minus 10 is equal to 2x plus 4. And now, combine like terms. 5x minus 2x, we transpose 2, is equal to 4 plus 10. 5x minus 2x, that is 3x, is equal to 14. And now, to get x, we need to divide by 3. Divided by 3. So x is equal to 14 over 3. 14 over 3 will be our final answer. Did you get the same answer? Now let's try number 3. 3x minus 4 over x minus 5 is equal to 3x plus 6 all over x plus 2. So our first step, we need to cross multiply. But before doing our equation, so look at our denominator. Our domain, or the values for x, must not be equal to 5 on the left side of the equation, and on the right side, x must not be equal to 2, because that will give us undefined. So cross multiply, that will become 3x minus 4 times x plus 2 is equal to 3x plus 6 times x minus 5. Then use the FOIL method. So 3x times x, 3x squared. 3x times 2, positive 6x. Next, negative 4 times x, negative 4x. Negative 4 times 2, negative 8. Is equal to 3x times x, 3x squared. 3x times negative 5, negative 15x. 6 times x, positive 6x. Then 6 times negative 5, negative 30. Now combine like terms. This will become 3x squared plus 2x minus 8 is equal to 3x squared negative 15x plus 6x is negative 9x minus 30. And combine like terms. Notice that if we're going to transpose 3x squared, this will be 0. So we can cancel that out. Then 2x plus 9x is equal to negative 30 transpose negative 8. That will become positive 8. So 11x is equal to negative 30 plus 8, negative 22. Get the value for x. So x is equal to negative 22 divided by 11. So negative 2. If we're going to substitute negative 2 plus 2, that will become 0, which is not applicable because it will give us undefined. So the value of x is not applicable. So we call this equation as x. It has extraneous solution. If the value of x, or if our solution will make our equation undefined. There is another way to solve this rational equation. Take a look at our equation on the right side, that this will be, or this can be cancelled out. So copy the left side of the equation, 3x minus 4 all over x minus 5 is equal to, let us factor the numerator, that is x 3 times x plus 2. 3 times x, 3x, 3 times 2, negative, positive 6, over x plus 2. Now we can cancel x plus 2 and x plus 2. The remaining is 3x minus 4 all over x minus 5 is equal to 3. Then cross multiply. So we have 3x minus 4 is equal to 3 times x, 3x, negative 3 times, negative 5 times 3, negative 15. Transpose 3x minus 3x is equal to negative 15 plus 4. This will be cancelled out. 0 is equal to negative 11. That gives us our extraneous solution. So we don't have solution for this. X is empty. So that is our example number 3. And the introduction for extraneous solution. Thank you for watching this video. Please make sure that you watch our tutorial video in inequalities and interval notation to better understand this tutorial video. Our topic is solving rational inequalities. Our root word is ratio. So we are dealing with our rational expression, rational inequalities. Let's try number 1. 2x plus 10 over x plus 3 is greater than or equal to 1. Again, 2x plus 10 over x plus 3 is greater than or equal to 1. So our first step is our inequality must be equal to 0. So we need to transpose positive 1. So 2x plus 10 over x plus 3 minus 1 is greater than or equal to 0. Okay? That is our first step. The inequality must be equal to 0. Now, simplify the left side of our inequality. So we need to find the LCD. Our LCD is x plus 3. So just copy x plus 3. X plus 3 divided by x plus 3, that is 1. So 1 times 2x plus 10, so 2x plus 10. Next, we know that the denominator of 1 is 1. So x plus 3 divided by 1, that is x plus 3, times negative 1. So that is negative 1 times x plus 3. It's greater than or equal to 0. Okay. In this case, we need to simplify our numerator. So copy 2x plus 10. Negative 1 times x. This is negative x. Negative 1 times positive 3. Negative 3. Over x plus 3 is greater than or equal to 0. Simplify our numerator. This will become 2x 10 minus 3 plus, okay, we need to combine 2x minus x, that will become x. 2x minus x is x. Next, 10 minus 3, that is positive 7, over x plus 3 is greater than or equal to 0. Okay. That is now our simplest form. Second step, find the zeros of our rational inequalities. So, find the zeros. Zeros. So, our zeros are x plus 7 just equate to 0. So x is equal to negative 7. Then x plus 3 is equal to 0. X is equal to negative 3. This is now our zeros. -7 and -3. Now, we need to locate in our number line. Plot in our number line. So let's say this is our 0, +1, +2, +3. -1, -2, -3, -4, -5, -6, -7, -8, -9. Locate -7. -7 is here. Okay. And -3 is here. Now let us check which of the following satisfies our rational inequality. So let us test the leftmost part of our number line. So you need to choose -8, -9, -10, -11. It's up to you. In this case, let us try -10. Like -10 or -9. Okay. Let us choose -10. So substitute our value of x to -10. If x is equal to -10. So -10, just change to -10 or substitute, +7 over x is -10 plus 3 greater than or equal to 0. -10 plus 7, that is -3 over -10 plus 3, -7. Greater than or equal to 0. Okay? Negative divided by negative, that will give us +3 over 7. It's greater than or equal to 0. 3 over 7. Is it greater than 0? Yes, it is. So, if x is -10, this is true. Okay. Of course, if x is -9, that is also true. And if x is -8, that is also true. All the numbers on the left side of -7. Now, let us test the numbers between -7 and -3. So, pick one number, either -6, -5, or -4. Let us choose -4. If x is equal to -4, then substitute -4 plus 7 over -4 plus 3. Is it greater than or equal to 0? Now let us check. -4 plus 3, that is +3 over -4 plus 3, -1. Greater than or equal to 0. 3 divided by -1, that is -3. Greater than or equal to 0. Is -3 greater than 0? No. So this is false. Okay. So the following numbers are not included: -6, -5, and -4. How about the numbers on the right side of -3? So let us check 0, because 0 is the easiest one. So if x is equal to 0, so 0 plus 7 over 0 plus 3 greater than or equal to 0. 0 plus 7, 7 over 0 plus 3, 3 greater than or equal to 0. 7 over 3 is greater than 0? Yes. So this is true. So we're going to get the left side of -7, because that will make our inequality correct and the right side of negative 3. So to write our final answer, open to negative infinity and 7, that is close. Why close? Because that is equal to greater than or equal to union negative 3 going to positive infinity. This is now our final answer. Negative infinity to negative 7 close, union close to negative 3 to positive infinity. So that is on how to solve rational inequalities. Now, I want you to solve this problem. 3x minus 15 over x less than or equal to 5 minus x. Okay. Try to solve this. 3x minus 15 over x is less than or equal to 5 minus x. This will be the checking of the problem. 3x minus 15 over x less than or equal to 5 minus x. That is your assignment in our tutorial video last time in problem number 1. Now let us check your work. Our first step, the inequality must be equal to 0. So let us move 5 minus x on the left side. So use the addition property of equality. 3x minus 15 over x minus 5 plus x is less than or equal to 0. Okay. This is now equated to 0. Now, find the LCD. Our LCD is x, our denominator. So x divided by x, that is 1, times 3x minus 15. So that will give us 3x minus 15. Or just copy because this is already equal to x. Now, x divided by 1, we have a denominator of 1 here, times negative 5, negative 5x. And x divided by 1 times x, positive x squared. It's less than or equal to 0. Now, simplify our numerator. Then arrange from descending order. So, x squared, 3x minus 2 minus 5x, negative 2x, minus 15 all over x is less than or equal to 0. Okay. Now, since this is quadratic, find the factors. So factors are factors of negative 15. The sum must be negative 2x. So that is x minus 5 and x plus 3. Let us check. Negative 5 times positive 3, negative 15. Negative 15 times 3, negative 2. Okay. For our next step, find the zeros of our inequality. So just equate to 0. X minus 5 is equal to 0. That will become x is equal to 5. So the zeros are 5. The other one, x plus 3 is equal to 0. So x is negative 3. And of course, for the denominator, x is equal to 0. So the zeros are 5, negative 3, and 0. Now, our number line so let's say 0, 1, 2, 3, 4, 5. Okay, I will adjust it on the middle part. Let's say 0, 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, and negative 5. Now, locate our zeros. Positive 5. So it's here. We have the 0 and negative 3. Okay, that's it. Let us test whether the numbers on the left side of negative 3 satisfies our inequality. Choose between negative 5, negative 6, negative 4, or negative 7. Okay, let us try 5. So if x is equal to negative 5, so negative 5 minus 5, negative 5 plus 3 over negative 5 is less than or equal to 0. Let us check. Negative 5 minus 5, this is negative 10. Negative 5 plus 3, negative 2. All over negative 5. Negative 10 times negative 2, that is 20 over negative 5. 20 divided by negative 5, negative 4 is less than or equal to 0. Is negative 4 less than or equal to 0? Yes. So that means this is true. Negative 4 is less than 0. Now, let us check these numbers between negative 3 and 0. Choose between negative 2 and negative 1. Let us try negative 1. If x is equal to negative 1. So we have negative 1 minus 5, negative 1 plus 3 over negative 1 less than or equal to 0. Negative 1 minus 5, that is negative 6 times negative 1 plus 3, 2 over negative 1 less than or equal to 0. Negative 6 times 2, that is negative 12 over negative 1 less than or equal to 0. Negative 12 divided by negative 1, that is 12 less than or equal to 0. 12 is less than 0, true or false? False. So this is false. That means if it is false, the numbers between negative 2 and 0 are not included. How about these numbers? 1, 2, 3, and 4. Choose 1. Okay, I will choose 3. If x is equal to 3. So change x to 3. So 3 minus 5, 3 plus 3 over 3 is less than or equal to 0. 3 minus 5, that is negative 2. 3 plus 3 is 6 over 3, less than or equal to 0. Let us use the cancellation method. 6 divided by 3, that is 2. So negative 2 times 2, this is negative 4 is less than or equal to 0. Is negative 4 less than 0? Yes. So this is true. And last, 6, 7, 8, 9, and so on. So let us choose if x is equal to 6. So 6 minus 5, then 6 plus 3 over 6 is less than or equal to 0. 6 minus 5, that is 1. 6 plus 3, that is 9 over 6. Less than or equal to 0. So 9 over 6 is less than or equal to 0. 9 over 6 is 1 point something. So this is false. That is not satisfies our inequality. So let us cross out the false. Okay. And now write in our interval notation for our final answer. So in this part, going to negative infinity, that satisfies our inequality. Negative infinity to negative 3. We're going to close at negative 3. Union, on this part, this is true. 0 is included. But, open or close? We need to open 0. 0 is not included. Why 0 is not included? Because if x is 0, that will give us undefined or extraneous solution. So we're going to open to 0. 0 is not included. To positive 5, we're going to close to positive 5. This is now our final answer. Negative infinity to negative 3, union, open to 0 to positive 5, close. This is our solution in that given problem. Thank you for watching Señor Pablo.